Welcome to this tutorial. I'm solving question number 11 of paper 2-1 May-June exam series of 2019. The question is related to the phenomena of radioactivity and the half-life. The question says a teacher carries out an experiment on radioactivity using the apparatus shown in figure 11.1. So in this apparatus we can see that a radioactive source is placed near a detector, and the detector is connected to a counter which shows the count rate or the number of radiations being detected over a certain period of time. The count rate is a measurement of the count during 1 minute, so it is showing counts per minute. State the name of one type of radiation detector. So the most commonly used radiation detector could be Geiger Miller detector. Next part, state one safety precaution that the teacher must take when using a radioactive source. So keep a safe distance away from the radioactive source. This is the most basic precaution. The teacher states that the emissions from the radioactive source are random in time. State what is meant by random in time. So randomness could be described as the time between emissions varies and is unpredictable. So there is no constant pattern between the radiations and the emissions. In the next part, the question says, describe how the apparatus is used to show that the emissions are random in time. So when the count is repeated for a certain period of time, the results are not the same. For example, we consider an interval of 10 minutes, and when we observe repeatedly the radioactive substance behavior or the count rate for 10 minutes, so every time during those 10 minutes the count rate or the readings are different from each other. So it means that the radiation is a random process in time and it does not show the same behavior every time. The next part says state what is meant by background radiation. So it is the radiation detected when there is no source present in front of the detector. So the radiation being detected without any source is called the background radiation. The teacher measures the count rate due to the source. Describe how the count rate is corrected for the background radiation. So there are two steps. First, we have to measure the count rate without any source and then subtract that reading from the measured count rate, and the time taken for the both readings should be same. So I'm writing first measure the count rate with no source present, and secondly subtract it from measured count rate for the same time. So for example, we were measuring the background count rate for 10 minutes, whatever value we got, we have to subtract this value when we measure the count rate with the active source present in front of the detector, and the time should be kept same. The next part says the corrected count rate is recorded for various distances d between the source and the detector. Figure 11.2 shows a graph of the results obtained. So this is the graph which is showing the count rate or the counts per minute, and it is the corrected value which is being taken after subtracting the background radiation and the distance between the detector and the source. So we see that as the distance increases, there is a little decrease in the count rate, but after a certain value of the distance, the readings fall or decrease very rapidly. Now the question says determine the maximum distance that the radiation travels in air. So the maximum distance it can travel is 4.5 centimeter, because here the radiation count becomes equal to 0 and no radiation is able to reach the detector after this. So I'm writing 4.5 centimeter. State the name of the radiation emitted by the radioactive source and give a reason for your answer. So it is obvious that the radiation emitted here would be alpha radiations or alpha particles, and the reason is that the range of alpha particles is less than 5 to 7 centimeters in air. So since the radiation is not able to travel more than 4.5 centimeters, so it is obvious that it is the alpha radiation being emitted. The next part says as the radiation from the source travels in air, it causes ionization. Describe what is meant by ionization of the air.